Good afternoon, my YouTube viewers. In this video, what we're going to be talking about is the confidence intervals for CEO management succession plans. So the question that we have is, of a survey of 210 CEOs, only 51% had a management succession plan. So what we're going to do in order to create these confidence intervals, we're going to write a program in Python to do it. And in order to write this program in Python, we're going to have to import some libraries. These libraries are necessary to execute the program. So the first library that we're going to execute is NumPy as NP, which is a numeric library. It calculates numerical computations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy.stats as stats. And scipy is Python's scientific library, and stats is a statistical module within scipy. So we're going to calculate our sample statistics. So a sample proportion is 0.51 because that's 51% of CEOs have a management succession plan. And N is 210 because that means they surveyed 210 CEOs. So now we're going to calculate the confidence level. In this instance, the confidence level is 0.9. You know, in previous videos, we said that the confidence level was 0.95, but we also said that it could be 0.9, 0.95, or 0.99. So in this instance, the confidence level is 0.9. So we're going to calculate the z-score, and we're going to use a normal distribution to do that. So z-score equals stats.norm. Norm is for a normal distribution, .ppf, and ppf is for a percentage point function. And then brackets, 1 plus confidence level divided by 2. So 1 plus 0.9 is 1.9 divided by 2 is, I think it's going to be 0.95. I think that's what it's going to be. So 1.9 divided by 2 is going to be 0.95. And then calculate the standard error. So standard error equals NP square root brackets sample proportion plus 1 minus sample proportion divided by N. So sample proportion plus is 51% plus 1 minus sample proportion is 49%. And then we're going to use the BIMDOS. That's brackets, exponents, multiplication, division. So multiplication comes before division. So 0.51 plus 1 minus 0.51. 0.51 times 1 minus 0.51, so that's 0.49. Divided by N, which is 210. And then you take the square root of that. And then remember, if you're going to do it by hand, which you don't have to do it by hand because that's what we've got a computer for, you have to use the sequence of operations for mathematical computation. So it's going to be brackets for exponents, multiplication, division, addition, and subtraction. So the multiplication is going to come before the division. But the computer's doing that for us already, so we don't have to worry about that. And then we're going to calculate the margin of error. So margin of error equals your z-score times your standard error. And now we're going to calculate the confidence interval. Confidence interval equals sample proportion minus margin of error, comma, sample proportion plus margin of error. So we're going to print out all these values. We're going to print the sample proportion, the standard error, the z-score for a 95% confidence level, And that's not correct. It should be 90% confidence level. And confidence, no. Okay, 95% confidence interval, margin of error, and 95% confidence interval. So the sample proportion is 0.51, that's 51%. Standard of error is 0.0345. Z-score for a 95% confidence interval is 1.64. Margin of error is 0.567. And 95% confidence interval is 0.45 to 0.56.67. And so that's it. That's it for this particular video. The next video, we're going to be talking about defective batteries, and I hope you decide to watch that. Thank you for watching.